All right, we were at example 6 here. So let's work on this example. I changed it. This is a 9x now. So we have x cubed plus 4x squared plus 9x plus 10 all over x plus 2. And we're going to try to find all the vertical asymptotes. So we want to know when this denominator equals 0 after we have canceled everything we can. So I want to know if x plus 2 can be factored out of here. And I think a cube function is kind of hard to factor, so what I always do is long division. This is the number I think might go into it, or that I'm looking for, because if that number doesn't go into it, then I don't care. So, why is this not writing? Oh, there we go. There, nice. Just a little delay, huh? All right. So if I think a 2 goes into it, oh, it's going to be really slow like this, huh? All right. Long division, you put the coefficients, and if there's a factor missing, like x cubed and then there's no x squared, then we would put a 0 here instead of the 4. But remember, you drop down the 1, multiply 2 times 1, oops, sorry. This is x plus 2, and we want to do the opposite because the factor is always x minus whatever you're dividing by. So x minus a negative 2 is how we get the factor of x plus 2. So drop your 1 down. Negative 2 times 1 is negative 2. Add these two together, so it's 2. Negative 2 times 2 is negative 4. Add these two together, it's 5. Negative 2 times 5 is 10. Negative 10, sorry. So 10 and negative 10 adds up to 0. That means that there's no remainder, so x minus negative 2, or x plus 2, does go into 1x cubed plus 4x squared plus 9x plus 10. And this is the other factor. So x minus negative 2, or x plus 2, is one factor, and the coefficients are what's left here. 1x squared plus 2x plus 5. So that's how the top factors, and then we have x plus 2 in the bottom. So x plus 2 cancels with x plus 2. So we don't have a denominator anymore, so this has no vertical asymptotes. Alright. Let's find the limit of x squared minus 3x over x minus 1. If we factor it, you notice that nothing cancels. So we know at x equals 1, we have a vertical asymptote. But how do we know what the limit is? Are we approaching positive infinity or negative infinity? Remember, with one-sided limits, you need to determine if it's a one-sided limit, you need to determine if it's positive infinity or negative infinity. We know that the limit will be infinity of some kind. And if it were just limit as x approaches 1, we could say infinity. But because there's a minus there, we've got to be specific about if it's positive infinity or negative infinity. So let's check out the graph. As x approaches 1 from the left, so this means from the left, you can see that the y values are approaching positive infinity. So this limit will equal positive infinity. You could figure it out algebraically by plugging in numbers that get close to 1 from the left, like 1/2, 3/4, 0.9, things like that. That's numerically, not algebraically, numerically. But you know it's going to be some type of infinity. Alright, so let's look at some examples of properties of infinite limits. If we have a function where the limit as x approaches c of that function is infinity, so that limit does not exist, and we have another function g that actually has a limit, so that could be 10 or 4 or 1/3 or whatever, but the limit of f of x is infinity. So think about the limit of the function f plus g. So what we're thinking about is infinity plus a number. Like, what's infinity plus 2? That's still infinity. Or infinity minus 2. That's still infinity. Infinity plus or minus any whole number or any decimal or any kind of number, any real number, is still going to be infinity. Because you can keep adding numbers to infinity, it'll still be infinity. Also, if you take infinity times a number, like what's twice infinity? That's still infinity, as long as that number is greater than 0. But if you have infinity times a negative number, negative 3 times infinity is a negative, if that number is negative. So when you multiply infinity by a number, or add a number to infinity, you're still going to get infinity. What about dividing? What if you take a number divided by infinity, like 3 over infinity? Think about what that means. It's a fraction, and the bottom of the fraction is getting bigger and bigger and bigger. So it's like 3/4, 3/5, 3/8, 3/10. What's happening to that fraction? 3/100, 3/1000. Remember, we're talking about a limit. So what are all these values approaching as the denominator gets bigger and bigger? 3 over 1,000,000. That's going to be a number that approaches 0. So if you have a number divided by infinity and you're trying to find the limit of that, it's going to equal 0. Let me show you why. So let's talk about this. Limit as x approaches 0 of 1 over x divided by 3 over x squared. If you do direct substitution, you get 1 over 0, which is undefined, which sometimes approaches infinity, right? If we're talking about vertical asymptotes, 1 over 0, that limit would be infinity. And you put 0 in here, that would be infinity here. So what's infinity divided by infinity? That's another indeterminate form. Remember, 0 over 0 was indeterminate, and so is infinity divided by infinity. You can take a number divided by infinity and say that that limit is 0, but infinity over infinity is a number we don't know, because it could be 1, it could be 0, it could be something else. It's many different things depending on the situation. So we have to analyze this situation a little bit more. So let's rewrite this complex fraction. 1 over x divided by 3 over x squared is the same as multiplying by the reciprocal, so x squared over 3. The x cancels, so we'll have x over 3. Now do direct substitution. Put 0 in there. 0 divided by 3 is 0. So in this case, the limit as x approaches 0 of this function is 0. So if you get infinity over infinity, it's just like when we had 0 over 0. You have to rewrite the function somehow so that you can do direct substitution to get something else. Remember, if you get a number like this, that is a limit that approaches infinity. If you get a number like this, that's a limit that approaches 0. Other than that, it's whatever the number is. So let's find each limit. The limit of 1 plus 1 over x squared. If you put you put 0 in, because the limit as x approaches 0, you get 1 plus something that approaches infinity. So what's 1 plus infinity? That's infinity. So the limit of 1 plus 1 over x squared is infinity. Let's try this one. Direct substitution, plug 1 in. So on the top we've got 1 plus 1, all divided by 1 over 1 minus 1. So we have 2 over 1 over 0. Dividing is the same as multiplying by the reciprocal. 2 times 0. So that's 2. And then 3 cotangent x. Oops, sorry. Back the truck up. I wanted to explain another way to think about this. So the 1 plus 1 can be 2. Sorry, it's not writing. There we go, 2. And then 1 over 0, you can think of that as approaching infinity. So if you want to stop right here and think, okay, this is approaching 2 over infinity, we just talked about in the previous screen, what's 2 divided by a huge number? That's going to approach 0. And 2 times 0 is 2? No, that's wrong. So, sorry. Thinking, talking, recording all together doesn't always make for good mathematical computation. All right, so either way you think about it, this limit equals 0. Now 3 times cotangent of x. Cotangent of 0, if we do direct substitution, let's think about what that means. Cotangent is cosine over sine. Oops, I did direct substitution there before I wanted to. All right, so 3 times cosine of 0 over sine of 0. Remember, what's sine of 0? Here's 0. Sine is the second number. So sine of 0 is 0. And then cosine is 1. So we have 3 over 0. What does that approach? As the denominator gets smaller and smaller, that approaches infinity. But we have to decide if it's positive infinity or negative infinity. Checking out the graph, cotangent, looks kind of like that. So as x approaches 0 from the right, we're going to be looking at this branch, so it's positive infinity. So we're good to go there. Alright, one of the problems on your homework asks you to write a rational function with vertical asymptotes at x equals 3 and x equals -4, and with a 0 at x equals 2. So let's think about what vertical asymptotes mean. If I give you a function and I ask you to find the vertical asymptotes, you're going to look at the denominator. You're going to try to find where the denominator equals 0. I've got two vertical asymptotes, so there are going to be two places that equal 0 in the denominator. If I want one of them to have an answer of x equals 3, so we'll have something plus something equals 0, so that's going to be in here, and we want the answer to be 3, what are these pieces going to be? X plus what? Hopefully you can see that it's going to be x plus -3, or x minus 3. The other vertical asymptote is going to be x equals -4. So what was this factor here? When we solved it, we ended up with x equals -4. It was x plus 4. That's how we get our vertical asymptotes to be 3 and -4. You can have anything else down here too, like times 7 or times another factor, but the other factor can't have an x in it because it has only vertical asymptotes at 3 and -4. And it has to have a 0 at x equals 2. For a fraction to equal 0, what part of the fraction has to equal 0? Remember, if we have a fraction like this, 5 over 0, that doesn't equal 0. If we have 0 over 0, that's indeterminate. What part of a fraction has to equal 0 for the entire fraction to equal 0? Just the top, like 0 divided by 3 equals 0. So we want the top to equal 0 at x equals 2. So what do we have to have on the top so that if we put it in the top will equal 0? Must be x minus 2, because if we put 2 in the top, then 2 minus 2 will equal 0. So there's our function. That's one possible function. You can choose other things to multiply it by, like times -1 or times a 3 down here or whatever. So these coefficients can be whatever they want, but you've got to have at least this much to make sure you have a vertical asymptote at 3 and -4, and you have a 0 at 2. Alright, I changed this assignment. So some of you on your cards said that you wanted to know the assignment ahead of time. It is on my calendar. I always post it on my calendar at least a week in advance, but here it is. You're going to do page 88, 1 through 61, every other odd, and page 95, 1 through 7, just the odds. Alrighty? So if you want to get started on that, then you can do the easy ones at home, and by the time you get to class tomorrow, you will be at the hard ones, and you should be able to finish before the end of the class period, and I can help you with them. Have a great night!